Here we are at example 3 from our 4.6 set of notes. Again, we're just talking about the quadratic formula. We're going to first identify our a, b, and c. So in this case, we have an a value of 1 there. And we notice on question 3 that we have things on both sides, right? Now, it's usually encouraged or advised that you want to keep your a value positive, okay? Now that kind of tells us what to move then to what side. So in other words, anything over here, we're going to bring to the other side. And we can accomplish that by pretty much inverse operations. So we're going to subtract 3x, and we're going to subtract 3 from both sides. So these are going to cancel. And when we do that, we have x squared, 1x squared, minus 3x minus 3 equals 0. It's important to note that the quadratic formula only works when things are equal to 0, when your quadratic is set equal to 0. Okay, so you need to have that occur first. Okay, that really helps us identify our correct a value, our b value, and our c value when you're plugging those in the quadratic formula. So our a again is 1, b here is negative 3, and c is negative 3 as well. Again, I always encourage rewrite the quadratic formula so you become more familiar with it. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Now let's go ahead and plug in our values where they belong. So we have x equals the opposite of b. In this case, b is negative 3. Notice how, again, 1 is from the actual formula, b just happens to be negative, so they're their own negatives, plus or minus square root of b squared, negative 3. And a lot of times I like to place my values in parentheses when I'm plugging values in, so negative 3 squared minus 4 times our a value, in this case it's 1, times our c value is negative 3, all over 2 times a. A in this case is 1. Now, a common trap, guys, is, again, I highly advise anytime you substitute those numbers in like we just did, you put them in parentheses. And the reason for that is what I've seen is a lot of times in the calculator, if you plug this in right there, a lot of students tend to put negative 3 squared and get negative 9. When in fact, it's actually negative 3 quantity squared, which becomes actually a regular positive 9. So don't fall for that trap. That's, again, why I normally put stuff in parentheses. Okay, and if you do that, I think you'll be much safer. So x equals normal positive 3 plus or minus, again, square root of 9 there we said. Negative 4 times 1 times negative 3 gives us positive 12. All over 2. So notice like this isn't really necessarily hard, it's just probably tedious. That's kind of more often what I hear. And then, bring this up so we have some more space. X equals 3 plus or minus 9 plus 12 inside those parentheses. We get 23 all over 2. And because, I'm sorry, actually that would be 21 rather, not 23. Now, when we look at our number 21, unfortunately, we cannot divide that by any perfect squares. So that would actually be our solution. And again, I prefer that answer because it is an exact answer. In ACT, they could represent it like this, just as a heads up. 3 halves plus or minus square root of 21 over 2. But they mean exactly the same thing. All they're doing is that butterfly, guys. Okay? That's all they're doing there. So again, though, that is example 3 from our 4.6 set of notes.